Hello and welcome to today's Rust Meetup. It is the 8th Rust Meetup that we have in for Linz here, and we are looking forward to an awesome evening together with you. Let me start by doing some community news. My name is Ryan Stropek. I'm one of the co-organizers of the Rust Linz Meetup, and I would like to tell you a little bit about what's going on in the community before we start with our first talk today at 6 p.m. First, let me say we really welcome you to this meetup. This meetup is brought by you by our coding club. It's the Coding Club Linz. It is a non-profit organization running multiple meetups, coding club for kids and things like that. Yeah, I think we can skip this one. Now comes the most important part. What will you hear today? What will you hear today? You will hear a talk by Florian Gilcher. Florian will kick off the day with a talk, a language-oriented talk about ownership and borrowing. And after that, Taylor Thomas is a guest speaker today. He is part of the Krustlet team, and he will talk about the rusting cloud. He will tell us about his experience in building a large-scale system based on Rust for Kubernetes and the cloud. We are really looking forward to both talks, and we want to say a big thank you to both speakers who take the time to do a talk at the Rust Linz meetup today. What about discussion and interaction? As always, we invite you to join our Discord server. Here you see the invite link. You can also find it on our website, rust-linz.at. There you can find a button, and we invite everybody to join our meetup, our Discord server, and there we will monitor the we will monitor the chat. Oh, thank you, Will. Thank you very much for your message. We will monitor the chat, and if you have any questions to our speakers, please let us know through Discord. We will relay the questions. Our speakers will also monitor the Discord server, and with that, we can provide some interaction. Now, let's go on with some community news. The first thing that I would like to draw your attention to is our weekly Coda Dojo. Coda Dojos are programming clubs for kids, and we run the local Coda Dojo here in Linz. The next online meeting is, as every week, tomorrow. Tomorrow's Friday, and so Friday afternoon is Coding with Kids. If you have kids, and if your kids speak German, at least a little bit, then take a look at our weekly program. We always publish the workshop programs Tuesday, Wednesday, something like that. And if you like one of the workshops, and if you want to join, or if your kid would like to join, just download Zoom, click on the link, and join the workshop. Next up are our friends from Female Coders. Female Coders is an organization here in Linz, and the Female Coders, they invite girls and women who would like to start in IT or who would like to enter the IT business, and they also do regular coding workshops. And their next study group will be on the 7th of April. Currently, their study groups are also online, so it doesn't matter if you are from Linz or from anywhere else in the world, you can join the Female Coders study group. And speaking of female coders, the female coders have something very special coming up. On April 24th, they are running a complete day, a workshop day. If that sounds interesting for you, take a look at the URL. Here is the URL. And as always, after this introduction, I will convert these slides to PDF and share them on our Discord server. So if you have no pen and paper ready, or if you can't make a photo or a screenshot now, don't worry, go into our Discord server. You will find the PDF there, and it will contain the link if that is interesting for you. Workshop day from our friends at Female Coders. Next one is our sister meetup. Let's put it that way, the Cloud Native Computing Meetup. Their next meetup is on the 30th of March, and I am sweating a little bit when thinking about that because I will be one of the speakers there. I will talk a little bit about security, zero trust, and organizational issues when it comes to DevSecOps and things like that. If that sounds interesting to you, I warmly welcome you there. I invite you to join us there. It is an online meetup, so you can join from everywhere in the world. Now, This one is really keeping us busy currently. The Global Azure Austria. Nearly the entire team of the Linz Meetup will speak there or is involved in some way with this event. It will be a multi-track conference with more than 25 speakers. It will be from the event, from the community, for the community. You will find cloud computing sessions there, development related sessions there. We have a security track. We have a data and IoT track. There is English and German content, and the entire event is part of the Global Azure event series, which is a series of events happening in 3 days. At the end of April, I think in Linz, we have it on the 16th of April, and you can take a look at the program. It's already online. We have a preliminary schedule online, and everything is visible on this webpage, globalazure.at. If that sounds interesting for you, take a look at the schedule and just take a look at the sessions. You are very much welcome if you're interested. Last but not least, we want to say a big thank you to our sponsor. Microsoft is sponsoring this Rust meetup, and because of that, we would like to mention some very specific offerings that Microsoft has. Microsoft offers every single month a series of free trainings. Most of them are related to the cloud, mainly the Azure cloud. They also have some very interesting meetups coming up in the upcoming weeks, and here you can find the link. The Azure immersion workshops are there. Most of them, I think, in fact, all of them are free, and some of them even are in English. So if you don't speak German, don't worry. You can take a look at them, and this website will tell you which workshops are in English and which workshops are in German. Speaking of Microsoft and our sponsor, they are also very active when it comes to climate hackathons. And there is a climate hackathon happening I think it is in April, if I can remember correctly. Please check out this link. Our friends at Microsoft, they asked us to mention this one. It's for a good cause. It's a really interesting thing, and you should definitely check it out. So thank you, Microsoft, for sponsoring this meetup. And yeah, if that sounds interesting for you, if some of these events sound interesting for you, please check out the links. That was the intro part. That was the welcome and the community news. As I mentioned, I will share these slides in the Discord chat. And with that, I will now stop my sharing and take a look. I hope that we have our first speaker already here. Yes, and here is Florian. I will ask him to unmute.
Hey.
Hi, Florian. Hi, and welcome to our meetup. We are very glad to have you here.
Thank you. I'm very glad to be here.
We are looking forward to your talk. Maybe we can do a quick tech check, and maybe you can share your screen with us, and I will make sure that everybody can see your screen well. Audio is fine. Everybody can hear you good. That's good.
You need to allow me to start my video.
Oh, sorry. That was my bad. I'm very sorry for that. Let me see here. And oh, it is enabled. You should be able to share your screen.
So, yeah, but I still can't share my video. But let's try this.
Oh, you can't share your video. You mean you can't share your video? Now you can share your video. I'm sorry.
Yeah, so there we go.
Yes, yeah, we see you.
See you
very good, very good. First thing, check. And
screen works
yes,
as well?
Yeah, works perfectly fine. Florian, where are you located? Where do you broadcast from?
I'm located in Berlin.
In Berlin, nice. We have a little bit of snow here in Linz today. How is the weather in Berlin?
Not good.
Not good, okay. But you don't have snow?
Somewhere Berlin rarely gets snow. Somewhere between rainy and a little bit murky. So it's very much going towards April.
That sounds like the perfect weather for a meetup evening, isn't it?
Yep.
Perfect. Very good. Very good. Florian, I would like to give the stage to you. The stage is yours. I guess you will introduce yourself in your talk, and we are looking very much forward to your talk about ownership and borrowing. The stage is yours.
Thank you. So this is actually the first time I give a talk about that subject, and I'm not sure how long the talk's going to be. But first of all, a little bit about myself. So, hey, my name is Florian. You can find me on GitHub as Skate and on Twitter as Argorak, which was basically the other nickname was not available. I'm a Rust team member, part of the core team and part of the Rust Foundation board since a couple of weeks. I am a Rust trainer and a business owner. I'm one of the co-founders of First Systems and its subsidiary Critical Section. The second one is focusing on Rust in safety critical environments and the things that you need to provide for that. And this is still a couple of years out. But one thing that I want to talk about is ownership and borrowing is always a big problem for people to get their head around, especially if you're starting out with Rust. And there's not a lot of concepts out there that you can map to it. So you need to learn it from they're completely new concepts, and you need to start grokking them pretty much immediately. And that is a little bit of a ramp-up curve to Rust. But one thing that I always find interesting is that they're often just seen under the aspect of Rust as a memory-safe language. But it's not only that. The goal of this talk is to take a little bit of a different perspective on both of these concepts from the perspective of systems construction, because that is something that, especially for newcomers, is much more relatable and gives it a little bit of a view into the hardships that they may find with it, because both of the systems are actually not that hard if you're holding them right. And the holding right problem is what I see people run into a lot, and that is, I think, the more inaccessible part. And I would actually just like to talk about 3 functions in this talk, and they're all called the same. They're all called write to file, and they write a string to a file, but in 3 different ways. Can you see my mouse pointer? Yeah.
Currently not. Yes, we can see your mouse pointer. Yes, okay. It works fine.
I should have made it larger. And the difference here is just in the way that we're passing all data. It's not even like the result type here. It's just these 2 parameters differ in each of the function calls. The first one is taking a file pointer in an owned fashion, and the string that is going to write to in an owned fashion. Second one is going to take the file in an owned fashion, but will get a loan out on the buffer. So it will take a reference, so the borrowing system gets activated. And the third one actually completely borrows here. And the perspective that I want to discuss these 3 functions under is not in the sense of, okay, these are references in memory, or these are own memory locations, or all of the things that we usually do, but rather from the perspective on component boundaries. I'll come to why component boundaries is a useful aspect here. But if we talk about components interacting, so any mid to large system, that is something that we need to deal with. We're also often talking about the concept called coupling. So how strong are 2 components interrelated? You can see that here in the first picture, we see 2 components with a low coupling, in that they don't have a lot of touch points, and the nature of the touch point is also very interesting. So the one does not rely on a lot of internals of the other. And the second one being quite the other way around, a lot of internals of the one here are also relying on internals of number 2 and vice versa. So they're kind of cross-related and do know a lot about each other. And that is what is usually expressed by coupling. There's the reverse concept to that you might have heard, which is cohesion, that works precisely the other way around, but expresses the same thing. So for this talk, I will settle on coupling because that's the one that I like more, in that low coupling is good, high coupling is bad, or at least harder to work with. There are reasons why you want to have high coupling, or why it might be useful to pay the cost of that, particularly performance. So this is a thing where you can select on how much you where you want to land in this equation. And Rust may have a very complex surface, but in the end boils down to a language that has 2 core components, which is data and functions. And everything where an action happens or data is getting passed is usually a call to a function in some way. So reading function signatures and seeing what we can read just out of the function signatures, you won't see a function body anywhere in this talk, is actually pretty useful. And being able to have some conclusions out of that, also particularly on what they say about the outside world and the inside world. And that particularly means that at all points where information crosses between components, you can see that at some point through some function call. To give an example, if you're passing data between 2 pieces of your system through a channel, the left side at some point will call send. And the other one will call receive. And those two function signatures are interesting for you. And if you talk about components, we also need to quickly talk about component life cycles. There are components with a life cycle relationship. So as an example, a component A calls into a rendering component B to render an image, yielding control fully to the renderer. So you have the maybe your application, and at some point it wants to render, so it calls into a rendering component, but does not do anything until the rendering is done, and then gets control back. This is probably an example where tight coupling actually makes sense. The application prepares data in a format that the renderer can render, so it knows a lot about the data format that the renderer needs, and maybe even allows the renderer to play around in some pre-allocated memory spot. There are components without a lifecycle relationship, where, for example, you have a database connection driver, which constantly works in the background, reading data from the network, putting it into buffers for you to then take and continue working in it. But it kind of has a life on its own, so it's spinning there. And you may submit, for example, a query to that database driver and tell it to notify you when it's actually done through, for example, an async runtime or some other mechanism. But the database driver may, for example, require resources in it by itself, for example, threads. And because that has a life on its own, decoupling it makes sense, because not knowing all the details of what this thing does allows you to change it, use a different one, use MySQL instead of Postgres, and all these kinds of things. So there's a conscious approach to not wanting to know too much about what that thing does internally, that both gives that driver the ability to change its own data structures all the time for optimizing it. Like, as long as they do not become part of the public interface, it's no problem. Which brings me to, why did I introduce these 3 functions? So imagine you have a component that is just there for writing to disk. So it accepts a file pointer. This is where you want to write it. It takes a buffer. And we have this function called write to file. And one component that calls write to file from another component. And if we pass ownership here, that particularly means the calling component is after that function call immediately freed of all duties to manage both the file and the buffer. The call component will take over this kind of this ownership, can destroy these things at any time, can turn the string into a byte buffer or whatever is needed. So this means the two components only have this one touch point, and the first component gives over all management duties to the other one the moment it is called. So we have a clear handover, and after that touch point, they don't need to know anything about the internals. They just negotiate at this point file and string. The section function that I had there, or the second function signature for the same process, differs a little bit in that it gives a string buffer to the component that is responsible to writing, but in a borrowed fashion. So the calling component keeps responsibility of the buffer. That particularly means it needs to keep it around until the call component is done with it. So it still retains some responsibility, and that means both of these components need to negotiate. And that is expressed through the borrowing system in Rust. The call component takes over ownership of the file to write to. So the first component does not care what happens to that. And the call component can break that coupling by copying the buffer. That is completely feasible. Can say, okay, I need to keep this around for longer. For example, I want to spin off a thread and immediately return from the write to file function. It may end up in a situation where returning a result may not be feasible anymore, but that's another thing. I want to put that, for example, I want to put that on a background thread, and to be able to do that, I copy the string buffer in some way. That is all possible. And the third one is coupling even a little tighter, in that all responsibilities remain in the calling component. And especially because we're passing in a mutable reference here, the amount of stuff that this component needs to fulfill becomes larger and larger. A mutable pointer in Rust, or a mutable reference in Rust, sorry, is unique. So the first component needs to make sure that no one has access to that file until the second component is done with it. That means more and more negotiation needs to happen between those. And particularly, files aren't clone and copy. So the second component is not even able to break this coupling, for example, at the cost of copying. This one still works. The second, problematic. And that brings me to a couple of rules of thumb. If you are dealing with a system that is larger than just essentially a module that does some stuff in memory, ownership is the preferable handover mechanism between components. And you see that in a lot of APIs in Rust. Standards that spawn takes ownership. A thread gets spawned, it takes ownership of all the data that it operates on. It is not working through borrowing. It particularly bans borrowing. especially when we're talking about components that might run in parallel with life cycles on their own. They should never borrow between each other because the borrowing rules are static. Something that has a life on its own at runtime is really hard to be described with a static rule set. And borrowing across components introduces a lot of pain, especially if we're not talking about passive components. And this is where I see most of the problems arising, is not even like I build a data structure and I do some small lightweight referencing into it, but rather people referencing between components just naively at the beginning, but running into precisely those problems that the larger the project gets, the harder those rules get to fulfill, while they should move away from using the borrowing system and rather focus on how they can use ownership to model things. Because ownership is a great method to ensure proper handover between components. I give up ownership and I give it to another component is a very, very common way to construct systems. For example, we have an HTTP server. The first part of the HTTP server accepts an HTTP request, does all the basic checking whether the connection is all right and whether it's actually well formed and whether the headers are there, and then hands it over to a router that starts selecting what function should actually be called and what action should be taken for that request. If you look at those APIs, they always work through ownership. Connection is accepted, we're done, we found that it's an HTTP request, next component, and we pass over ownership rather than any kind of borrowing system. Modeling that with borrowing would be extremely hard, if not impossible. Quick warning, coupling is a good mental concept to figure out whether you should select borrowing or ownership. Coupling may arise from other behaviors though. There's a bonus slide here that if we talk about a structure like this, where we actually use shared data through an arc, we end up in a situation where it is not easy to read from the signature what actually the interaction between those two components are. So also reading function signatures in Rust only gets you that far. At some point you need to read what the actual components are doing. Especially when it comes to responsibility. If you're talking about borrowing, a lot of the responsibility is still with the owner, so the one that lends out the reference. But in these cases where we're talking about shared smart pointers, then this becomes less clear and might need some more work to establish. As a final slide and pointers for especially beginners, if you want to observe this kind of behavior in practice with some easy to use types, I can highly recommend you to have a look at the channel API with how senders and receivers work, and particularly why sender and receiver are different types precisely because of that. And channels facilitate ownership exchange between components. So if we imagine the picture from the beginning with those two low couple components with the green thing in between, the green thing could be a channel where on the left side you put things in and on the right side you get things out. ARC and RC break data coupling over the lifetime that it remains in memory, because ARC and RC make sure that data remains in memory as long as there's parts of the system using it, at the cost of mutation. So that is a trade-off here. If I want to, because immutable data, components reading from a section of immutable data in memory does not, they don't need to care about each other. Once they introduce mutation and writing again, we're back to not square one, but maybe square three. where they do need to find some way to negotiate. There are, for example, great types for a memory saving optimization pass if you want to try this out. These are rather simple constraint types that will help you a lot in the beginning. And there's types that are consciously coupled. So for example, if you look at the mutex interface, which is also rather accessible, there's a type called mutex, which can produce a mutex guard, which represents that you locked the mutex and that you currently have access to its inner pieces. And the mutex guard is consciously coupled with the mutex and cannot get out of range of it, so to say. So you cannot stop referencing the mutex and but still keep the mutex guard around. The same goes for vector. The iterators of vector, all the iterator types, iter and iter mood particularly, they cannot live without the vector being around. And so this is a very useful method for ensuring iterability, because iterators do not make sense if the base structure is not around. And this is what the borrowing system in Rust very well enforces. So if you're writing these modules and data types where these kinds of relationships forcibly exist, then it's the system to read into, up into and buy into. So the conclusion here is ownership and borrowing have an interpretation from the perspective of systems construction. And if you are used to that, it might sometimes help to take that one. If you run into problems with borrowing and you fight with a lifetime checker all the time, it might be the case, and this is a case I observe a lot, is that what you're trying to do is you're trying to borrow and reference the memory of other components that have an active life on their own. And if you take that stance of how can I make sure that, with a component that is arbitrarily working around its memory all the time, and the second one working in parallel, can I find a static rule that makes sure references to the other component's memory always stay valid? It's pretty hard. And in this case, well, it's not you, it's the system. Borrowing in this case is just not the right solution, and references are not the right solution. And that isn't even subject to Rust. That is the same in a lot of other languages as well. Just that Rust actually denies you to writing those references, but the fix there is not to understand the borrowing system better, but to actually move off of it and try to go towards owned types. And yeah, and ownership is the most useful tool to decouple systems, and really, really useful for one to have. And in my opinion, actually, the more important of the two concepts in Rust. And I hope I gave you a little bit of a different perspective on why that is and why you should reach for it by default, essentially. Okay, thank you. That was my...
Awesome, awesome. Thank you very much, Florian. Thank you very much. We can, do you still have time for a few questions and chatting a little bit about this topic?
I'll stick around.
Very good. I have two questions already, and I ask the folks who are watching through YouTube or through Zoom, please join our Discord server and use the Meetups channel to ask questions. I already got a question from a community member, so I will put mine to the end and relay a question to you, if that's okay. Are you already in our Discord server? So do you see the questions, Florian, or should I repeat them?
if you could please repeat them.
Of course. Alexander is asking, coming from a heavy embedded background, I was wondering if, Florian, you could share your opinion on the usability and actual industry usage of Rust in the embedded space. Do you expect Rust being run on a significant percentage of embedded applications, let's say 20%, and in which time frame?
Oh, yeah, I can answer that question.
It's not related to your talk, but I hope that's okay if we open it up.
Yeah, okay. Perfectly okay. Good. So maybe let me start with a little bit of insight. So actually, the company I formed, Fair Systems, was formed in 2018, and one of the goals of the company was actually to start working in classical environments like network development and all of these kind of things. But because one of our co-founders is part of the embedded working group, to also invest into Rust and embedded. And turns out 2 years later, that is the biggest amount of our work. Like we do most of our work actually in the embedded space on client work. So that is one view into that. The second part is, yes, I see Rust coming to the embedded space. There's a couple of not problems to solve. There's a couple of things that I still see as necessary for it to break through. And the first one is large companies, sponsors, in the sense that everyone I spoke to that is considering adoption is kind of on the fence of, we'd be interested in that, but is there someone else around? So more companies who actually actively speak about that they're using Rust on embedded, rather than me having to hint at that I know people that talk about it, would be extremely useful. I think that is I literally think that is currently the biggest blocker. The second part is, this is also maybe a little bit coming down to also movements in the embedded industry as well. Is support for architectures that the LLVM currently doesn't support is something that you need in the automotive. For example, Infinity Tricore is still very classic. I ran into an issue recently that the LLVM does support PowerPC, but not its short. It's short encoding for the ISA. And it's like it's stuff like this that is I wouldn't say a constant annoyance, but it's like this. It's more like the tiny things, the tiny blockers, rather than is Rust in itself ready for this. It's more like, is Rust ready for this microcontroller? Is there a driver for this? Do we have bindings to, for example, a Bluetooth library, because we don't have a Rust Bluetooth library yet, and all of these kind of things are much more the problems to fix. And I do see Rust going into that direction. You may have seen that ARM became a sponsor for a tier one target, a sponsor for Rust last year. So they are the second tier one target that we have. And I see that as a direction where things are going in.
Okay, thank you.
That answers the question.
Yeah, absolutely. I think that answered it perfectly. And Alexander, I would like to mention that we already had here at the Rust Linz Meetup talks, which were especially related to Rust and embedded programming. Maybe you want to check out rust-linz.at. We have the recordings of all our speakers on our website, and you can watch them, and maybe you find some interesting insights there. Florian, I have another question here. I think it's a very interesting one. I personally do a lot of work with kids and young coders who just start coding. And Piotr is asking whether, first he says, thank you for your interesting talk. And then he is asking whether you can recommend any exercises or side projects that would benefit them or him to better understand the concept of ownership. He thinks of things like very well well-known tutorials or maybe implementing a certain data structure like a linked list, I think he would like to have some tips from you how we should get into this topic and dive into the things that you just mentioned in your talk.
Yeah, so on data structures, I would like to punt on the linked list question. I'll come back with a talk on how using raw pointers is perfectly fine. Because I think particularly on the topic of implementing data structures, there's a lot of things to talk about there. I think useful exercises for dealing with ownership. The Async Stud book.async.rs has a pretty extensive tutorial on how to write a small chat server, and that basically hands around everything to channels, like anything that involves a complex, semi-complex system that needs to pass data around, for example, handling multiple clients. Chats are good in the sense of the client handling in and by itself is very, very simple. You need to accept strings and you need to send it out to all of the other connected ones. Like, don't punt on chat rooms and all of these kind of things. Like being able to break down the exercise to these are components interacting, and clients are often pretty natural and approachable things. Also, I can highly recommend working with the threading API rather than the async APIs, at least for starters. I'm not going to say that async APIs are bad, quite different. It's just the threading model is rather easy to understand and very quickly accessible just through the standard lib without putting a whole runtime system with its own support library and all of that on top. And the threading interface has a very nice way on how it forces you to pass ownership between different threads. So something that works in parallel on a shared resource or does handoff between multiple threads works really well. Again, I think a chat would actually be interesting with one thread doing the whole brokering and one thread per client handling a connection. I'm not sure if there's like the one tutorial that I would recommend because the topic is just so pervasive, I would say.
Yeah. Okay. Thank you very much. I noted down both tips. I think you said book.async.rs, right?
Yeah.
Yes, I already shared this link, and I also shared a link into the Rust book with a chapter about threading. Maybe this is an interesting, as you suggested, an interesting point to start for beginners here in Rust. And we especially want to be a beginner-friendly meetup here. So thank you very much for pointing that out. Now, the next question comes from Bram. His name here is Bram in Berlin, so maybe he's also from Berlin. And it's going deeper into what you were telling us. I will just read the question, and I hope it will come over to you naturally. What about resources that you want to call a method on multiple times? Would you recommend that the method takes a mutable self, or rather a self with an additional self return value? Did you understand the question? Hard if you can't read it. Do you have Discord on your screen? I can forward the message to you if you want.
I actually have it. I just trying to model.
Yeah, I just sent you in a direct message the question again, so you can read it as a direct message. You don't have to look for it. And maybe you have some thoughts on it.
So are we talking, for example, about things like builder patterns here? So basically, Rust gives you, in all situations, gives you three options. Ownership, borrowing, or mutable borrowing. And there's actually an order there. Ownership is the easiest to handle. The shared borrowing, so immutable borrowing, is a little harder because it gives you an amount of constraints on how long the value needs to live in memory. And mutable borrowing is actually the hardest because it also has the uniqueness constraint. If you, I would always work for ownership in that. But when you talk about calling functions multiple times on a type that you already own, take mutable self and call as many as you want on it. Because if you're the owner, you already can make sure that you got single access for the time of the method call. And then I would take mutable self. There's the pattern of taking ownership and then returning ownership again for method chaining. That's why I was talking about builders, where you have things like builder dot like request builder dot method get dot and
setting a header and setting the response code, things like that.
Exactly. There, basically everyone has moved to using mutable references and not returning self, rather actually returning the mutable reference out of the function to make sure that you can chain, but that you can also drop it and use another pattern there. But builders are actually an interesting example of the thing that I was talking about, because the moment you're done with the construction, you usually call build and you get the actual request object, or the actual request structure. And that moment, you would take ownership in validating the builder because you're done building, turning it into a request. It's not quite component handover, but it's a moment where there's a clear cut in time. We say, okay, now I turn the builder into the actual request object, and so if I can, I would always use your ownership because it's easiest to use. But on these kinds of shorthand, like that also plays a little bit into the topic in these kind of where you're basically just calling a function and then you're returning and you're operating on the same type. Both of the principles that we're using are really, really easy to use because we're only shorthand borrowing. Borrowing gets hard if you're doing it over a time over a complex system over multiple parts of that system. While when you're just calling into, for example, a builder, it gets really easy because you're basically just doing that for one function call up.
Yeah, Brand just noted that he was, for instance, thinking of like an instance handled to a gRPC service or something like this.
Well, you said service, so probably ownership.
Yeah. That one's fair. Brad is just typing some comments, but while we are waiting for his response, what I see when I work, especially with newcomers in Rust, that they have sometimes problems understanding lifetimes, especially situations where they have to use explicit lifetimes. Do you have any tips, any ideas or mental concepts that you can give us that makes it maybe simpler to approach the concept of lifetimes?
Yes. Lifetimes are weird. Not because like the way lifetimes work is actually rather simple. You have a region in memory where a type is alive, and that's dictated by ownership, and everything in between needs to, like everything that refers to it needs to be part of that. The problem is that Rust also has the lifetimes always exist. The problem is that Rust also has the lifetime feature and the lifetime syntax. And the problem is the lifetime syntax is a declarative way in a otherwise imperative language to describe and validate that these things exist. But the compiler does a lot of good assumptions around this, but it takes a pessimistic assumption on that basically all ingoing, like if a reference flows out of a function and a reference flows in, it says those two belong together. So there's this region outside of the function, and everything inside, everything that comes out of it is not allowed to live longer than that. And this pessimistic assumption is sometimes wrong. And if you need to break this pessimistic assumption, then you need the lifetime annotation feature, because you need to explain the compiler some more. And given that it took me a while to even like get the scene set the scene for the moment you actually need to annotate lifetimes, that means this is a little more fringe than people expect it to be. The usual fix for that problem is own the data longer and don't throw it away. So the problem is pretty often more on the left, in that if the compiler tells you, hey, this data is not in memory for long enough, then the lifetime feature is not the thing to interact with, rather than actually keeping the data around for longer. So, for example, by putting it into, like, allocating it on the heap, putting it in an ARC, where you have control over the lifetime of the data. If you want to keep things around in memory for longer, ownership is the solution, because ownership dictates how long data is in memory, and not the lifetime system. The lifetime system models how long it, the lifetime system models how long it is actually in memory, but it does not. It describes it. It does not. It does not dictate it.
Mm-hmm. Okay, thank you very much. I think that made it clearer, and I thought I took away a lot of things that I can use next time when I describe lifetimes to somebody. Brad had another question. It's rather long, so maybe I can copy it while I ask you a shorter one. I come very much from an area where I have spent more than, I think, 15 years of my life doing C# programming. So programming in a managed language, this is where I primarily come from. And therefore, I have to deal with a lot of people who come from these managed languages, and they ask me, hey, Rainer, this ownership stuff, why should I take a look at Rust? That's complicated. I have a managed language like C#. So therefore, it solves all my problem. I don't need the concept of ownership and things like that in C#. So why? What I would like to ask you is, are they right? Are managed languages like C# and Java, they don't have the concept of ownership because they don't need it? Because these languages are inherently safe? Or do these languages have those concepts too, and people are not aware of it because it's only a concept in the documentation and the compiler don't shout at them if they manage it wrong?
Well, I mean, I'm wearing the right shirt. That's the Ruby shirt. Yeah, that's actually also my background. I think this is a common mistake when selling Rust as a language, is only boiling down ownership, and it's a common misinterpretation of the language as well. Seeing ownership and borrowing only as a memory management technique. It kind of is, but the memory management that we're talking about is particularly memory lifetime management. So how long do things remain in memory and when are they deallocated? Problem, for example, in all managed languages, if you have a file pointer and you're dropping it, which happens the same, it will be closed the moment the garbage collector gets to it, which means you may have a file pointer for too long. So that means people still need to remember calling close. Another thing is, and that's a very common problem, is proper handover of data between parallel running components, particularly threads. So the one thing that the ownership system gives you is, for example, completely and thoroughly ensuring that data being passed between one thread to from one thread to another is complete. And actually, one of my flatmates at university has written his master's thesis on writing a system for making sure that references, like if you pass references between Scala actors, all references and all inner references are passed over. And his conclusion was, this is hard to bolt onto a language. You need to write a new one for that. And we had a very fun chat 5 years later around that. So I think it is important that we also discuss the usefulness of that system and the rigor that system has in other aspects. Because first of all, like ownership basically means like boiling down from the principle of you can get as many handles on a type as you want, down to you can only get one handle. And when I approached Rust back in 2013, I was like, okay, so I'll program with that. Like, I've been there, done that. I went through the same process. But figuring out that this is beyond memory safety, although concurrency safety, to use part, like the concurrency safety in Rust is concurrent memory safety, and Java and C# are not memory safe in the face of concurrency. These are useful. Like the whole component handover part was much more teasing to me than anything else, because the speed concerns. I was doing Rails back then, and I was writing high performance applications in Rails to well-constructed caches and good caching behavior. So like the thing where I don't care about the performance because most of the time my application doesn't even run. In those kinds of settings, we need to find other ways, very useful ways, how to explain people to what the usefulness is. That being said, if I want people to be angry at me, Java programmers and C# programmers have actually a very good handle on the abstract nature of Rust. So it's a good background. It's a good background to do Rust in.
Yeah, I fully understand what you mean. And essentially what I discovered a few months ago, I read the documentation of a certain piece of code in C# about so-called array pools. And guess what? In the documentation, you find a description of the concept of ownership and borrowing and lifetime, but it's just in the documentation. And I always refer to that when discussing this issue with people who are interested in Rust, because it is a problem in managed languages, and thank you for confirming that. That made me sleep better at night, because I was questioning myself whether I got that wrong. Okay, thank you very much.
The question is more, which thread is currently responsible for this piece of data? And suddenly you're back to that question.
Yeah, okay, thank you very much. I'm not sure if I'm allowed to ask that, but I will. You are the first speaker here who has some role in the Rust Foundation. And I know that many people here in the audience, maybe as a kind of closing, ask themselves, what is it all about? What is this Rust Foundation? What are they doing there? How does that look like? Can you give us a 5-minute quick personal chat about what is this Rust Foundation? What are you doing there? And why is it important for us? That would be so valuable.
Okay. Let me peel that onion. So first of all, the Rust Foundation is almost now over a month old. Exactly. So just be aware that a lot of things are still in flux. It has a mission though, and I think that mission is interesting. It is there to support the Rust project doing its work. And that's a little bit different from what the last decade was basically the focus of foundations. And I've been a little bit part of those discussions. I was also in the foundation setup group. I think that is helpful to clarify. I'm not only a board member, but was also a part of the group who actually facilitated the handover. So the big problem that I think open source had 10 years ago, and also 20 years ago, it was basically making people aware that open source exists and is a feasible option. 10 years ago, we were talking about, okay, how do we scale this? How do we find more contributors? How do we get more people into the project? Now, the Rust project is already has fluctuating between 250 and 300 team members. The reason I was raising the hand was I was about to say staff, but they're not staff, they're team members. And a sizable amount of infrastructure behind that. And we have 6,000 contributors or something like that. So the problem that modern large projects that are independent run into is making sure that the maintainers can accept contribution. So the Rust Foundation has a little bit of a focus towards making sure that the maintenance bandwidth and the quality control bandwidth actually remains, and that the people working on Rust are well supported. This is a little bit different to other foundations that are more outside facing. The Rust Foundation is slightly more inside facing, but the outside facing part is that we want to talk very publicly about what we're doing to that effect. The other part, and this comes more a little bit from my my background, is I've been part of the community team a long time, and I'm part of also the Berlin Meetup and the Rustfest project. So that I dislike maybe I start with that. I dislike the term community management, and I don't think that we will engage in that too much. In like community support, yes, but community management implies that there's something to be managed and that there's someone giving out not orders, but that there's like something on top, like. And I don't think that model has worked or does work very well. I've been subject to places that we've been managed to that like that as a meetup organizer, and I always felt bad about it because pretty often either you don't get the bandwidth that you need for something that you actually want to do, or the little bandwidth that you get, you could just do without. So that it's incredibly hard to scale, and given that Rust has such an active community. There's with things like, for example, Rustfest has formed the Rustfest project, which is giving out support to other conferences. There's also a lot of things that are there already that have a life on their own, and which we rather interact with. That being said, I'm incredibly happy on how many people from the project have volunteered to be on the board and are doing extremely good work there. And I'm also very happy with the people that sponsors have sent, and we're productively working there. Just to be clear, we're currently setting up the structure, bank account, legal handover, like the whole handover of all the things.
Yeah. I can imagine that. That's definitely a large project. Yeah, thank you very much for telling us a little bit about why this Rust Foundation is really important. I fully agree and I fully understand, and thank you for telling us a little bit about your work here, your everyday work in the Rust Foundation. With that, Florian, I would like to invite you again. Maybe you want to join our Discord server. Bram wrote another little piece of code. He said it's not a question, just an observation. But if you want to stick around a little bit and maybe ask questions or answer questions, that would be really awesome. For me, I want to say thank you. Thank you for taking the time. It was a pleasure having you here. And yeah, I hope you enjoyed this hour here at the Rust Linz meetup.
Yeah, thank you. I'll be around and stick around the Discord and watch the other talk.
Very good. Thank you. Thank you very much, Florian. Thank you for being here with us.
Thanks a lot.
With that, we still have a few minutes until 7 p.m., but I think our second speaker is already inside of our meeting. Is he? Taylor, are you there?
Yes, I am.
Ah, awesome. Oh, and video is already working. Very good. I think you are not from Europe. You're not broadcasting from Europe. It seems like you're broadcasting from outer space, but probably you are in the US, aren't you?
Yes, I wish it was Cloud City, but I am in the western part of the United States. So it is just barely the afternoon for me.
Barely afternoon. Okay, for us, it's already dark and we are in deep winter. I always ask the same question. We have speakers from all around the globe. So how's the weather?
It's actually quite nice. We're at about, I think about 14 degrees. And so it's fairly warm here. It's starting to warm up. We'll
Very
probably
nice.
have our first few days of close to 20 here in a week or two. So.
Oh, that sounds like spring weather.
Yes, it is. And I'm
Awesome.
excited for it.
Great. Thank you. Thank you very much. Taylor, let me start by saying thank you in the name of the entire Rust Linz community. We really enjoy having you here because here in Linz, we have a very active community when it comes to cloud computing. We have a cloud native meetup. We have some very large, also very cloud-oriented companies here. For instance, the company Dynatrace has a large development center here in Linz. So the cloud community is very strong. And obviously, as you can see, the Rust community is also very alive. And you bring together both worlds. So both communities sent out newsletters to their community members. And we all look forward to your talk to hear about why and how Rust can help when building solutions in the cloud. With that, I think you will introduce yourself in your talk, right? Will you?
Yes.
Very good. With that, I would like to hand over to you. The stage is yours, and we are looking forward to your talk. And to community members, please let your questions coming in the Meetup channel on Discord, and I will relay them to Taylor. Taylor, I hope that's okay for you if you do it that way.
That's perfect. Actually, and because I'm using Keynote, one of the disadvantages of Keynote, it basically takes over all the screen, so I can't keep an eye on it. So however, I would like to answer questions during the whole thing. So feel free to ask them, and you can interrupt me.
Okay, I will. So if we have urgent questions, I will give them to you. Good. The stage is yours. Thank you very much.
Okay. Go ahead and share the screen and start my slides. Oh, hold on. Of course, it decided to change screens.
Yes,
Give me one second.
I think that is cool. That's a natural thing. It always starts slides on the wrong monitor. I know that very well.
Okay, hold on. Just switching it around.
No problem.
That always seems to be the thing. Okay, there we go. We see it now?
Yes, we see a slide. Yeah, very well.
Perfect. Now let's go ahead and get started. So my talk is titled The Rusting Cloud. And my name is Taylor Thomas, as was already introduced. So we're going to go ahead and I'm just going to give a quick introduction to myself here so we can so you can all know who I am. I also like to title this Why My Opinion Might Actually Matter. First off, I'm a Krustlet and Helm core maintainer, and we'll talk a little bit about Krustlet in a little bit. If you're at all in the cloud native or cloud software space, you've probably at least heard of Helm, and that's a package manager for Kubernetes. I've been doing Kubernetes and container things for a long time. So basically since the beginning of Docker and for quite a while with Kubernetes itself, I came to Rust by way of Go, which makes a lot of sense given my background. If you like to tweet out or ask me any questions or anything, or reach out on GitHub or Slack, you can see there, right there's my social media handle. I left my Twitter handle in the lower right-hand corner on all the slides in case you want to tweet about something or ask any questions or make fun of my slides, whatever you want to do. So if you can't tell, I'm pretty straightforward and frank with everything. I'm going to be completely honest during this talk about the various strengths and weaknesses of Rust in cloud development, but my opinion is still just my opinion. So keep that in mind. I have been doing this whole cloud native thing for a while. So hopefully that gives you some confidence that I'm not totally making this up for you. So yeah, that's just a little bit about who I am. Now let's go over what I'm going to talk about today. So first off, I'm going to give a brief intro into our projects and what Wasm is, and then answer the question, well, but why? Why are we doing this? And then I'm going to talk about using Rust in cloud development with good, bad, and ugly. Now I know we kind of have a mixed crowd here. Some are more Rust newbies, some are very experienced with Rust, some are experienced with cloud software, and some are not. So this is going to be focused on cloud software, and I'm going to be talking about some things that if you're very familiar with the language, you'll be like, oh yeah, I know that. But there might be some other things in here that you'll also be able to pick up on and learn some things. So this is meant to be the whole thing is meant to be a knowledge sharing presentation. So if there seems to be some consensus or there's questions coming in to dive into another topic more in depth, or if people want to skip something, I'm completely fine with that. I don't have to cover every single thing I've written down here. I want to make sure that we can cover the things that are of interest to people here. And then at the end, we're also going to have a little bit, that's kind of a tongue-in-cheek joke about it being a cage fight between Rust and Go. And that's a question that people ask us a lot. So I threw that in there as a little bonus content so we can cover it about. So Yeah, the Rust in Cloud development section, when we get there, I'm going to use the kind of classic good, bad, and ugly overview of what we found in Rust that's very useful, things to keep an eye out for, and so on. So let's go ahead and intro the projects that we have. And first, to understand all the projects that I'm going to kind of use as a backdrop here, I need to mention what Webassembly is. So Webassembly is known as Wasm. And if you're not familiar with Wasm, Wasm is a compiled binary that can be run in a browser through JavaScript, except that's its main use right now. And so it allows you to have the speed of compiled code while still running in something like a browser environment. However, WebAssembly is not just for the web. There's a new specification called WASI, so the WebAssembly System Interface, that gives a set of ways of interacting with a host system, no matter what operating system it is. And so one thing to be aware of is it's relatively new. It's only been around for about 2 or 3 years, and it's not all the way fleshed out yet, but it's on its way there. And when I say not very fleshed out, what I'm meaning is that's very, very true. There's plenty of things missing, like there's not a full networking specification yet. And there's actually like, for example, we released an experimental HTTP support project that's meant for Wasm, and it's just meant to bridge some of these gaps that are in there right now. And so WASI is a way that means I can now take these WebAssembly binaries and run them on every single kind of system. And I'll talk more about those advantages in a sec. So here are the projects. Now these projects are what I'm going to be drawing from as I go over the different parts of Rust. And now all of these are real world projects that are where there's a fairly large code base involved with various servers, clients, code machinery, all the things you'd expect from a project that deals with distributed systems or cloud software. These are all relatively recent projects from us, and they all fall into that like cloud native bucket in general. So we'll be using a lot of examples from Krustlet and then a few from these other projects as well. So I want to give each of them kind of a proper introduction. Now, all of these projects are open source. So if you're interested, feel free to contribute code, bug reports, whatever it might be through these projects. I'm not really going to give a super detailed intro to the WASI HTTP project, but I might mention it in context of other things. And I just wanted to drop the link there so that people can take a look at it. So these are all under, and I guess that I just realized I forgot to introduce that. So Deus Labs is my team at Microsoft. I work for Microsoft, but my team works primarily all in the open source space with these kinds of technologies. So that's where that's from. So first off, Krustlet. Now that first line, that first bullet, looks ugly, but that explains where the name comes from. It stands for Kubernetes Rust Kubelet. If you're not familiar with Kubernetes, the kubelet is the thing that runs on a node inside of a Kubernetes cluster. So its primary purpose is to run Wasm modules. So modules are the name of the compiled binaries. So it runs these Wasm modules within Kubernetes. Now we have inside of this a idea of providers. Now this comes from another project called Virtual Kubelet. We stole this kind of idea of having a provider, meaning that you can implement any sort of thing that you want to. We've heard some people are trying to do some stuff with systemd. We've had people try to re-implement container support. You can implement anything you want with these providers. Now we've created a few that are just mainly targeted at WebAssembly, so Wasm targets and Rust. Now the reason why I say Rust here is because there's some really good reasons that we're going to talk about of why you would want Rust to write a Kubernetes thing. And especially like a provider. So you don't have to remember all these concepts, but that's like, you might see that some of that terminology and things as you look around. And it basically allows people to write whatever sort of kubelet they want within Rust. Now, inside of the project, there's actually 3 crates that we export. One of them is kubelet, which is the actual thing that runs the kubelet component. We have OCI distribution, which is a partial Open Containers Initiative, like the Open Containers Initiative interfaces that implementation. And then we have a project called Crater with a link to what that is, but it's a fully featured compile time checked state machine in Rust for building Kubernetes operators and other things, which is used inside of the Krustlet project. Next up, we have Bindle. So Bindle is an aggregate object storage system. The easiest way to explain this is a silverware drawer or a flatware drawer. So if you have your, you generally have a drawer that contains your forks, your spoons, your knives, and all the little fancy things you need for more fancy dinner, or if you're doing, also you generally have so many different utensils in there. And so for breakfast, you might only need something like a spoon. But for a fancy dinner, you might need a spoon, fork, a knife, and then like a chilled salad fork or something else. Now, all of these things are related. Most people generally don't have a separate drawer for every type of utensil. And so the idea was that a lot of things in the cloud native space, they don't allow you to put related objects all together. And so in taking this example of the silverware drawer, if I want to select a certain number of WebAssembly modules that I want to use depending on what kind of system I'm on and how much processing power I have, this allows me to select the specific set of binaries that you need for a project. So the first use case this was we created it for was enabling our Wasm and Wazi projects. The idea being that we can pull, like I said, those modules and then use them the way we want them to. However, there could be some really other interesting use cases for this. If it is interesting to you, reach out to us on GitHub. But it also turns out, we kind of stumbled on this, that it could be useful for securing software supply chains. Bindle is strongly typed and versioned. So there's basically a manifest of what objects, it's called an invoice in Bindle. Each of these things are signed by the person who creates it and the server that hosts it. And it must have an exact specific Semver version. So this is just an interesting project that I'll show some code from as well, but is tied into this WebAssembly module. We also have this WAGI project, or WAGI project. So it stands for WebAssembly Gateway Interface. And yes, you read that right. It is a CGI implementation that basically allows WASI modules to act as HTTP handlers. So you're able to compile it, whatever your code's doing down to WebAssembly, and then have it act as a handler for a specific HTTP endpoint. So this was just another way we went around enabling HTTP for WASI. And Bindle can be used with WAGI to pull the proper modules down, or you can upload modules. We're still building that project out, but that's another one that we have. So we get to this, but why? Like, why did we write all these things in Rust? Why did we choose Wasm? Why did we integrate this with Kubernetes? Why did we even mess around with cloud stuff at all? Isn't Rust a systems programming language? Those are the questions that people often ask. So let's dive into why. So first off, let's talk about the Wasm and Wazi side of things. I like to title this, but wait, I already have containers. Why do I need something else? So first off, these two are fairly self-explanatory. So there's more security. Wasm modules run in a completely sandboxed environment. You have to explicitly grant permission for them to be able to access anything. Density, we're talking about an order of magnitude smaller in size. So if you have a well-crafted Docker image, you're talking probably 20 megs, 10 megs, depending on what kind of thing you have in there. If you've built your containers right, you can generally have, or built your Wasm modules right, you can generally have them between 1 to 5 megs, depending on what they're doing, which is much smaller. And also the things needed to run them, you don't need a full Docker runtime, you don't need any of that. You just have to have a Wazi compatible runtime that can run these things. So it's a lot easier to run these in other places and to pack them more tightly. Now, just a point here, this isn't meant to completely supplant Docker, but because there's certain workloads that are never going to be worth porting to Wasm, even if everything was in place. But this is where we get to it is actually run everywhere to an extent. We like to say, if you've been in the cloud space at all, and you've used Docker, we like to say, oh, well, Docker is work anywhere. And it really isn't. If we're just being honest with ourselves, it's a Linux technology. Now there are Windows containers, but they're very different from a Linux container. They aren't the same thing. If you have an Nginx container that's running somewhere on a Linux server, you cannot run that exact same container on Windows that isn't also running a Linux VM. So it's not actually run everywhere. And you contrast that with WebAssembly, and it's closer to this dream of having a universal binary. So I can compile a WebAssembly module on my Mac that I have right here, and it will run on my Windows machine out there. It will run on a Linux server in the cloud. It'll run on a Raspberry Pi. It's going to run everywhere. And that is very, very powerful and helpful. So between the size shrinking and that, it's super useful. And like I said, you have this overhead of Docker and other container runtimes that makes it really hard to run on embedded devices. And there's some interesting use cases that people started to try around using WebAssembly on embedded devices. So that's one of the big reasons we actually have Krustlet, is to enable those kind of people to try that out. So the next big thing here is Rust and Wasm are great friends. So if you've toyed around with WebAssembly at all, you'll see it really quickly. But a lot of the tooling in the WASI space is actually written in Rust. And it has a built-in, you can easily use Rust up to add a target for building or compiling to a WebAssembly target. And so because of that like built-in support, it made it a natural choice for building WebAssembly-centric applications like Krustlet or Waggy in that language. So another thing that answers kind of the why here is about Kubernetes in the cloud. So for many people, especially those who, late adopters in terms of companies, that Kubernetes is the cloud. Now, I don't necessarily agree with that. I don't think that should be the thing, but whether I like that or not, Kubernetes and containers have become synonymous with running applications in the cloud. Most people who have migrated to or are currently migrating to the cloud have interacted with Kubernetes in some way. So we created Krustlet as a way to allow people to try WebAssembly in a familiar environment. So you can start to see how all this adds up. We have Rust, which has great support for WebAssembly, and then we're tying this into the cloud. And Kubernetes was the good place to give people a familiar place to try these things out. But also, we discovered Rust is a really great fit for working with Kubernetes and other cloud applications with similar APIs. And that's where I'll mention this. And so I know we're getting here, and I'm sure some of you are asking like, oh my gosh, Taylor, you are at a Rust meetup and you're just barely getting to Rust. And I get that, but all of this stuff is really important to understand how we use Rust in cloud development, and what its strengths are and what its weaknesses are. So here's just kind of an overview of the things that we've seen in Rust. These are the high-level reasons why we chose Rust. So the first one is safety, which is one of the oft-touted features of Rust. To quote one of my coworkers when we were kind of compiling some of the information around this, he literally sent me in all caps, "No damn null pointers," because safety is required, and unsafety, as I'll call it, is explicitly called out with the unsafe keyword. I can easily grep through code and find where all of my unsafe calls are. And so I know exactly where something like a null pointer or memory issue can happen because of Rust's strict ownership rules that keep everything very safe. The rest of these are pretty self-explanatory, I think. I already explained the Wasm support, and most of us who've used the developer tooling in Rust, such as Cargo, know like the developer experience truly is top class. Now, the extensibility one might have you scratching your head a bit. And so I'll explain more about that in the next section. But basically, Rust as a language makes it very, very easy to design flexible and extensible APIs, which isn't necessarily true for all other languages that are common in the cloud software space. We're talking Go and Python and some of those other those languages. It's a lot harder to design flexible and extensible APIs. So were there any questions yet that I should be aware of before I continue on?
Yes, there have been questions, but your colleague, Radu, I think is his name, already answered them. So he took over the job.
Thanks, Radu. Let's go ahead and dive into the whole Rust in cloud development. So this is all Rust in context of cloud development. These are answering the questions, or what are the experiences we've had? What have we liked? What was hard for us? What should you watch out for when you're starting your own new project? And so these are all based on real experiences and code from our projects. Now that these projects are a little bit bigger than just kind of toy projects that we do on the side. Now, some of what I'm going to talk about here can be found in the blog post I have linked on this slide. This is a blog post I wrote about a month ago, but we're going to be diving into more details and other things that's just in that blog post. And you'll be able to ask me any follow-up questions here at the end. So let's just dive right in. So let's start off with the good. So this is not just about the good things. This is about like how things went with our projects and how we felt Rust really showed its power. So first off, let's talk about traits. We have absolutely loved the trait system in Rust. If you're coming into building your first cloud software project, you'll immediately see how useful and flexible and expressive it is. In particular, we really love the conversion and reference traits. So this is like asref, from, try from, deref, from string, all those kind of types. And those are the great examples of why we consider traits to be better than most other interface style types that we've encountered in other languages, because the type itself doesn't have to implement an interface to be used as another type. Deref is a really interesting one to us because you can basically use that object as the underlying type. If you're not familiar with that, that's exactly what happens when you use the owned string type. Most of the methods are actually implemented on the underlying borrowed string, so ampersand str. Most of them are implemented on that and not on the owned string type, but you're able to access both methods because of the deref trait. Here is an example from our Bindle. Sorry, this is Bindle. I was about to say Krustlet, and that wasn't right. So this is from Bindle. And it's just a simple example of how this is super helpful. So right now we have this type that implements try into, and we have a custom ID type to make sure that the ID fits the strict requirements we have for a Bindle. And so what this allows you to is to pass in any type of string or anything that can be parsed as an ID into this, and it implements a certain type of error type coming back out. So while the function signature looks more complicated than some other languages that you might be used to from the cloud space, it ends up being extremely easy to use as a consumer, because you can pass, I think it's about 8 types when I tried to calculate it all out to this function, and all of them work properly. Now, the other thing that's really nice, and you can see this here, is we have the idea of traits can declare associated types. You can still have generics even in an interface context. So right here, you see error. So there I was able to specify a type that implements the error trait in Rust. And so because those were all tied together, I was still able to use this very generic try into interface with my own custom error type. And that's very, very useful. The other thing to think about this is if you're familiar with a lot of cloud APIs, and especially Kubernetes, you have types that are all very similar, but you can perform different actions on them. And so in Go, which most of the Kubernetes libraries are written in, you have a separate interface for each kind of type of API type. In Rust, there's actually just a single generic type and client that can access any Kubernetes style objects, which is so useful and cleans up code so well. The other good thing we found is Enums. They are very, very helpful, especially we found in error handling. Enums changed how most of us think about errors, because Rust enums are not just single values, right? They can carry associated data with them. And each variant can have a different data structure. They're kind of like discriminated unions from other languages. And you can work with these different cases using pattern matching. And so because they're also a full-blown type, you can then also implement methods on that type or traits for that type. So the big value here is that you don't have to bundle a bunch of possible cases into a single type to pass into or return from a function. And working with the cases is safe because the compiler tells you if you haven't matched everything, and also there's no need for optional fields here that might only apply to certain cases. And so this allows for code, or it encourages, I should say, code that processes enums to be have very clear regular layouts. and it makes for some very beautiful code and generic. So right here, you can see that I have an example error type. This is kind of a pared down error type from Bindle. And I'm able to have totally different data associated with each type. And then when I go down below, I'm able to unwrap and do things with that data very, very well. This is very helpful in really anything that involves like an API or network call, because there can be so many things that fail. There can be something with the network that fails. There can be something with the service is offline. There could be something where you have an invalid request, or the request, and it can tell you exactly why if the request needs more data. All these things are very common interactions, and Rust has easily been the best way to handle those kind of situations in our experience with things like enums and other types of error handling. I mean, you can see too, because enums can also contain generics. This is one from Krustlet that allows us to specify a very specific state type when you're transitioning from one state to the next. And that is that generic type added on to all the power of the enum is very, very helpful and very flexible. So the other thing we've run into that is extremely useful inside of at least Kubernetes, and I think a lot of different cloud applications, is macros. So writing macros can be a little bit finicky if you haven't written one before, but let's just use this example to walk through what we were able to do here, all of which is useful for cloud software. So in Kubernetes, there's this idea of something called a custom resource. It's an arbitrary resource that you can tell Kubernetes to handle as one of its normal API types. And so people use this to extend on top of Kubernetes. But inside of other languages, you have to import full other libraries or other things to either compile the right code, or it has to be generated code. With a macro, this is created at runtime using the macro as it compiles. So this custom resource derive allows you to go through and specify just a few arguments saying, here's what it should be. And then the data that we actually care about inside of our Rust program, and then derive the whole implementation for it automatically. And you also see in there the very classic serialize and deserialize, which to us is just absolute magic compared to many other languages, because you can derive these implementations, and then anything that implements the SERDI data model, you end up being able to then, just because we've derived these, be able to serialize it to any type you want. YAML, TOML, JSON. There's more types than that. Those are kind of the big ones we see in the cloud native field. We're also able to derive a JSON schema for this. And all of this is done. So now, instead of having lines and lines and lines of code or generated code we have to handle, this is all just a derived block that, if we include all this formatting and stuff to make it look nice, is maybe 10 lines of code. And that is extremely clean code and easy to kind of figure out what's going on. So that's something that, as you come into Rust, either as a newbie or as someone doing cloud software, like, I think we find macros useful anywhere in Rust, but there is a distinct joy in using them in the cloud space because of how flexible they are and what they do for you. So just keep that in mind as well.
Taylor, can I interrupt you for a second?
Yeah.
You asked me to relay questions, and I wasn't fast enough, to be honest. There is a question concerning enums. Yeah. Matthias is asking whether there is any specific reason why you didn't use a library for error handling. He thinks that this error would really reduce the code needed. Any thoughts on that?
Good question. So actually, I paired that off of here just to keep it simpler. This is using this error underneath the hood. So we have derives and things under here we have the derive error, and then we also have the error type, the error tag on each enum variant. And so this actually takes it and prints it out. The handle error was also a simplified case of what it was doing. We're actually doing some like logging and other things inside of the handle error function, but the example was simplified so it wouldn't completely take up the whole slide or two slides. So yes, that's a good point, and good. Thank you for reminding me to bring that up. There's some error handling libraries that are meant to work with enums like this and clean up a lot of the code. And that's what we actually use. It's called this error, and it allows you to derive and then specify error messages for each enum type, which is exactly what we do inside of our errors, especially inside of Bindle, because Bindle is implementing an API and also a client. Krustlet's a little bit different because we have to handle Kubernetes errors, which are a little bit more loosey-goosey. So good question. Were there any others?
Currently not. I think that's the only one which was unanswered. So
okay. Sweet. Thank
feel
you.
free
Good
to
question.
go on.
Okay, now another good thing to be aware of here, this is on our very high on our list of impressive REST features, is a whole amazing set of mapping, unwrapping, and iteration tools. The built-in result and option types, combined with all the mapping methods that are associated, and like if let or let variable equal match, and then being able to match on something, makes it really easy to handle errors or missing data in a very simple and easy to read format as well. And it also nudges you towards clean and readable error handling patterns, such as the try operator, so the question mark, which is really helpful for people who are new to the language. After coming from various types of error handling, including exceptions, and then the way Go does it, coming here and seeing that wonderful syntactic sugar of the try operator was so nice. It's very helpful to people new to language. And I know that when I've been helping people come into these projects and start working on it, they're able to read and understand what's going on with error handling very, very easily. So this block right here is a little gnarly, but this kind of shows there's the whole suite of like chainable filters, maps, splitting, zipping methods, similar to how LINQ and functional programming languages handle collections, along with the all-powerful collect method. So this is 20 lines of code that does a whole ton of work for us and shows off most of these features. So what's going on in this code block is we're trying to find what data that's called a parcel in Bindle, which doesn't matter here, but how many data buckets we're missing inside of a Bindle. And so we're able to go through all of the things we expect and then iterate over them and then map them into futures, which then we can take all those futures that check if they exist on disk, collect, like wait on all of them, and then join them back all together. So basically this is a fan out and fan in 20 lines. So that is very, very helpful, especially when you're doing some of the code that happens a lot inside of cloud computing, and not just cloud computing, but anywhere really. But a lot of what we have to do is kind of massage data from one source to be able to use it. And these chainable filtering and mapping and all that just makes it so easy to massage that data and get it into the format we need to be able to either return or to use that data that we're getting. So like I said, the block's a little gnarly, but we do a lot here in a very small amount of space. Now, we also have inside of the good is this dependency management. So we love Cargo. I'm not going to spend too much time on it because I'm hoping people are at least somewhat familiar with Cargo. But the fact that you can have conditional compilation and you can patch in dependencies from other places and only include parts of the code that you need with features. These two examples kind of show that. So we have a CLI that's using clap that instead of having people pull in clap and everything with it, they can opt into it using a feature. And you can see above how we're doing that in various dependencies. We're able to select only specific features of some generated API objects. We can add additional features in or make them optional so that we only enable them when we need it. We can also work on a crate locally, but when it gets pushed with the right version. That's like the OCI distribution line there, which is all quite useful. And the other thing that I can't say enough about is the Rust community. So the Rust community is absolutely amazing. It's not only just inclusive, but it's also very responsive and helpful for newcomers. A recent example of this is we were having a deadlock issue in Krustlet with Tokyo, and all the core maintainers of Krustlet had just been like working on it for a week going, what is going on? And so we asked a question. Well, I went over and asked a question on the Tokyo Discord channel, and one of the core maintainers responded very nicely in less than 5 minutes. And then not only did they provide some very helpful and useful information to me to be able to troubleshoot, they also came in and went to the PR and dropped in a few more suggestions. And this isn't the only time I've seen that kind of behavior. It's something I see all the time in the Rust community, and you'll never be made to feel like you're asking some sort of stupid question. People will always respond with kindness here. And so I really, really enjoy the Rust community. So you'll always find people out there, even if you're doing something completely crazy, which is a lot of the stuff we've done around Kubernetes, and people will still be out there to help you out. So let's kind of go over some of the things that we consider like the bad and ugly. I'm going to kind of gloss over some of these. I don't want to spend too long, but let's just talk about some of the things you need to be aware of that we've kind of run into with our projects. So first off is Doxing Clarity. So we've noticed an interesting pattern in a lot of our crate in lots of different crates and their documentation. That's something to be aware of as you consume and as you write your own crates. So docs are actually sometimes very unclear what is happening in the actual code. So they describe functionality well, but we generally have to go digging through the code to figure out whether it's an actual fully like zero cost abstraction, if there's possible side effects to what we're doing. So like we don't know sometimes if something is copying under the hood, or does the file handle get flushed when I call this function? And a lot of those things aren't very well documented. And because of this emphasis on zero cost abstractions, we just kind of assume sometimes we have to handle it or don't handle it. And so it's not documented very well. So this happened to us in Krustlet with Stack Overflows on Windows, which I couldn't put here. It's too large, but we're basically Krustlet runs a whole bunch of futures that are all running different tasks for the system to work properly. And what happened is when we started trying to get it to work on Windows, it would just Stack Overflow. And we're like, well, what's going on here? Well, it turned out in our newbie Rust brains, we forgot to think about that when we were selecting on all these futures, it said that it needed to be pinned. And so everything was pinned to the stack, which is kind of the default of how when you pin something, it works in Rust. But it turns out we didn't necessarily need to do that. And we didn't understand what kind of abstractions or things were going on there because there was no cost. And so we were just pinning to the stack and it was taking up way too much stack space. So once we figured that out, we were able to pin it to the heap because we're fine with using things from the heap. And so that's just something to keep aware of. Now up here in the slide is an example that's related but slightly different. So as users, when we're trying to find out how we can customize behavior by implementing a trait, we end up jumping through like a million different functions, looking at all the trait bounds before we can figure out what we need to implement. And oftentimes these traits are in other crates. So this is an example from the absolutely wonderful Tonic crate, which allows you to use gRPC connections across and use gRPC files to generate the proper code for it as well. But you look here, there's this make connection URI, and then you have two associated types that are related to it that need to be send and static, but like, what are those types? What has to be implemented? And so you would click through to make connection. It has its own things, but it also has to implement like async read and async write. And you just go down this big chain. And so there's like 3 or 4 distinct bounds, 2 with different traits. It turned out that all that was actually needed was the code right below, which is super simple. And we found that in the examples directory. So something to be aware of coming into this is if something looks confusing, try to make sure you go look at the examples directory of the project because they might have something there. But if you're somebody who's writing a crate, make sure you link to an example for something that's this easy because it turned out to be super simple. But as someone who was looking through this, trying to figure out which traits and things I needed to implement the first time, it was very difficult for a first-time Rust person figuring this out. So just make sure that you document and link. And please note that right here, these are the old docs that we saw. They actually, since I've written this and we've talked about it, they actually added in a link to the example of how to implement something for this function. Another thing to be aware of that we've run into in a lot of our projects is that in the Rust ecosystem for at least the cloud computing and like HTTP things, there's still a lot of missing features. So one thing that we ran into recently is we found out there isn't much support for multi-part content types in HTTP requests, except for form data. So this is not like a complaint against any specific developer of the crate. We think this is more due to Rust still being newly popular and its primary use case being systems programming. But in this cloud space and really application developers in general, there's just some gaps in the functionalities. We'll talk about the async space in just a second, but there's a lot of things with HTTP that aren't completely there. You have different HTTP library choices instead of 1 or 2 de facto ones or built-in support. So up here is an example of one of the worst ones we had to deal with. So Unix domain sockets on Windows. If you didn't know, you can actually do like Linux sockets on Windows machines, which is something we had to do for Krustlet. Now, that's all built in the standard library for Unix, and it's not in the standard library for a good reason, because Rust supports back to something like Windows 8, and this wasn't added until Windows 10. But there's no maintained crates to do this in an async way. So this is not a problem with Rust itself. I'm not complaining about Rust itself or the people who write these things, but if you look at all these unholy things we had to do with the code, just don't ask me what that reinterpret cast is doing. You don't want to know. But we had to go implement basically all the reading and clear read ready and add read ready and all that stuff in from someone else's crate and kind of copy and do all this stuff because it wasn't there. So you're going to run into gaps, and it's a perfect place where you can contribute back to the community if you find that interesting. Another thing is that people like to complain about the learning curve of Rust. Now, my personal opinion on this is that Rust does have a bit of a logarithmic learning curve, like what's showed here, that there's a very steep initial learning period of about a month, but it levels out pretty quickly. And in our team's experience, after about a month, a developer is just as productive as they were previously. Doesn't mean you're still not still learning. It just means that you're able to be as productive as you were before. But now that we've been releasing several different crates and things, there's a few more bumps in the road to be aware of, and the bumps in the learning curve, I should say, as you start writing your own crates and doing things. One of them is that there's a learning curve around designing APIs, particularly when working with an API that uses generics or trait bounds to make it easy for public consumption. There's a certain amount of knowledge we've had to pick up by trial and error about how to use them in a way that doesn't end up being messy for us or messy for the consumer. And I've refactored my code several times at this point to fix these kind of messes. You just have to look at the Git history of Krustlet to see all the fixing we've done there with some of those. And this is where, if you have experiences and things to create any training material or documentation, this could help ease that part of the learning curve, because it was something we didn't really anticipate coming in, but now that we've done a lot of it, that is definitely part of the learning curve that not many people mention. You just have to learn how to design APIs and design things well inside of Rust. So let's finish up with the ugly. I didn't want to, this isn't like, there's only one topic here, and it's really about async and async runtimes. But to be really clear, I want to emphasize, I'm not trying to rag on any of the async runtimes or contributors. In fact, like I said in that story before, they're an absolute joy to work with. And also, I think yesterday or today, they're just releasing a new async working group that we've actually contributed an initial story to kind of capture how we can improve the async story, especially for application developers. But I do want to point out that in the cloud software space, this is the part that is the most rough for people. And honestly, it really is impressive what the core team and runtimes like Tokyo have done within the constraints of Rust. And you really can't complain when your concurrent code is guaranteed by the compiler to be completely safe and correct. It's saved us from plenty of bugs already. But with that said, let's talk about it. So one of the things to be aware of is that there are competing and incompatible runtimes. So there's multiple runtimes that are available. Tokyo and Async Standard are kind of the two major ones. And you kind of have lock-in once you choose a runtime. Now that makes sense from a systems engineering perspective that you have multiple runtimes, but from a cloud software perspective, it is quite frustrating because you come from Go where you can just say go run, and it just runs. You don't have, or you just can shove it off to have it run asynchronously. And so having different runtimes is a little bit different than most other languages. And I know that you can make it possible to run across multiple runtimes, but it's difficult. And if anything in the stack only runs on a different runtime than the one you're using, you have to basically bake in some sort of shim or thing to wrap it to be able to work. It keeps getting better, but it's just, you have to be aware of it. Something to note here is that the core team has been stabilizing a lot of APIs into the standard library, like the stream one should be landing soon. And we have the futures one that allows standardizing easier and reduces that lock-in, but just be aware of it. The other thing that we've noted is there's some ugly code and nested futures problems. So here on the left is something from Waggy. You can, if you're familiar with Rust, you'll see why all these clones and moves and stuff are needed for memory safety purposes. But and part of this is also how the hyper API works. But you move, clone, move, async, move, clone, move, like 3 or 4 times all in one thing to make this work, which it's just kind of, it reads poorly. It's kind of hard to follow along why you need to do it. And you kind of like, we had to play around with this for an hour to figure out which moves and which clones and which things we needed to make it meet the FN mute and all the other stuff that's going on. So it can add to some weird, ugly code issues. But on the right is something that's probably the one that can be a little bit worse when it comes with the ugly code and nested futures. So this code right here is actually what caused the Stack Overflow before we boxed it properly. But right here, we have to like call each individual thing, fuse it, box it, pass it into a select, handle each of the things. And this is only part of it. There's like another set of tasks that have to run, and then we have to wait on all of them. So we end up with very deeply nested futures as these things go along, which can really like bloat your stack size and give you some problems there. So just be aware that that's there, and we're always around to help if you run into that issue. And then last in this section is Cruft and Bloat. And this happens with async. What we've noticed is that it adds a lot of cruft and or bloats your code with all the different incantations and things you have to do to make it all compile. When you compare this to other languages like Go in the cloud space, it's kind of a hassle in comparison, and it's something you need to be prepared to deal with. So on this left one, this is us implementing async read for an async type. If I had $1 for every time I had to re-implement async read, async write, or a stream for a type, when I just end up forwarding that call down the call chain, I'd be a rich man. And this particular example kills me because this is already an async type in every way, but to be able to wrap it with the proper things, I had to go re-implement async read on top. And as a developer, I really don't want to have to do that. And it's this whole chunk of code that really, in the end, is not doing much for me. On the one on the right, the other thing we run into is that there's opaque types littered everywhere. Because everything is like hidden behind the future trait or a stream trait, everything returns an impl future and impl stream. So you can't store it on a struct for later use. You can also see this happen with like your docs when you have an async trait, because you have to wrap it in the async trait macro, and it creates a very, very ugly doc. So it just adds cruft and bloat that you're probably not used to. I mean, like I said, the benefits outweigh these problems, but you have to be aware of it. Okay, finish up for the bonus round here, Rust versus Go. So interestingly, something that we found at least very interesting is that one of the most common questions we get when we talk about Krustlet with people is, well, why didn't you use Go? And how does Rust stack up against Go? I personally don't think it's as much of a flame war as people present it to be, but there's some important quick comparisons here that I want to talk about. First off, what do we miss from Go? What we miss from Go is an ease of concurrent task scheduling. Like I mentioned, all I have to do is say Go and the function name, and it just runs asynchronously or concurrently, not necessarily asynchronously. There's also a batteries included standard library, including HTTP support. I know there's good arguments for not having like HTTP thing built into the standard library, but it sure is helpful in Go. It's also easier to onboard new developers. It's much easier to get started on a Go project than a Rust project if you haven't done either one of them. Now, what do we not miss about Go? Dependency management. And I don't want to sound like a broken record if people have ever followed me on Twitter or read any of my other blog posts, but Go dependency management is just not good. You can ask any of the Helm maintainers on my team or any of them at all. Cargo just makes our lives in dependency management so much easier. So as someone who's developed really large projects against the Kubernetes libraries and API, it's an absolute nightmare to upgrade or add any library dependency because they all have different versioning schemes and specific hashes and branches. The other thing is if error equals nil. Error handling in Rust is much better. We really like the idea of an error as just a value that you get in Go, but Rust enforces it rather than Go's approach of just hoping that the programmer does the right thing. And then there's no generics, or even with the new generics that are coming in, it's just, like I mentioned with the trait system, we love it. It's much better than anything Go offers. Go's governance model is also being controlled completely by one company, and that's led to various community problems and project issues. Rust has a very open community model that we've talked about, the Rust Foundation, and it's not singularly controlled. There's no collections or iterator function, and there's no safety. And this isn't unique to Go. but it's important when we compare these two. It's really easy to end up with a null pointer in Go. And like I said, in Rust, it's impossible without unsafe. So to summarize that, when do we use each one? When do we recommend to use each one? So for Go, small, quick projects, a true microservice, so very small microservices, or super deep integration with very specific cloud tooling. For Rust, we recommend it for larger projects, anytime you need a flexible API or if there's safety or security requirements. So the summary of that is that Go is a great tool for the small projects and microservices that need to be written quickly or with ease, but we don't really recommend it for new projects or large projects. Large projects quickly become bloated due to that error handling, lack of mapping and iteration tools, generic support, bad dependency management. That's not to say there aren't large projects that do well with Go. We have plenty on our team that do it as well, but the overall experience leaves a lot to be desired. So anyway, that is a very quick overview of all the different things we've learned here. So I better leave some good time for questions or anything that people want to ask.
Awesome, Taylor. That was a really great presentation. We had a lot of chat going on in Discord and people discussing various things. I currently don't see specific questions. We have a lot of comments and people pointing each other to some libraries or blog posts. Before we go into any questions, it would be so great if you could spend another few minutes after your talk, maybe take a look at our Discord server, and maybe you see one or two comments where you would like to put your 2 cents on it. Yeah, that would be really fine.
I just started looking.
Very good, very good. I have one question to start with, and I ask the community members to come to let the questions come in Discord so I can relay them. I have one. Can you tell us a little bit about the status of your Krustlet project? Is it something that it is ready for production? I know it isn't, but is it something that we should take a look at now? For which projects? Where can people get involved? What is the status of your project?
That's a very good question. So I'm going to preface this with, although I am one of the core maintainers, I'm going to speak purely as my own opinion here. But I think really from what the conversations I've had, I think we're feeling kind of the same way. So we're very close to getting towards a 1.0. And what does a 1.0 mean for us? It means that we're not going to break your APIs anymore, like we have, if you've been following along for some reason for the whole time. We're not going to, basically no more major breaking changes, but it doesn't mean everything is feature parity with like a normal Kubernetes kubelet. It's enough to get you running. So at this point, we've done enough with it and have enough testing and things in place that it can be used. The big question mark is around networking, and that will likely be pushed to after 1.0. That's not a final decision. And people can just kind of bring their own networking, just because how networking is done varies wildly depending on which kind of thing is implementing it. And so right now, at this point, it's very stable, and we're going to respond to bugs. We're going to do things. It's still marked as experimental because we haven't hit that 1.0 phase. But if you're interested in Wasm at all, and especially if you have Kubernetes, it's very much ready to just start giving it a try. You can consider it to be like in an alpha beta-ish state right now, where you can start trying it out. I wouldn't necessarily run production workloads on it yet, but we're getting very close to that. And then to give us the feedback and also help update our guides. We have some guides for some of for 3 or 4 cloud providers, AKS, EKS. I think we have one for GKE, and I think we have one for DigitalOcean. Or no, maybe just Linode. Anyway, a couple different cloud providers. And so if you have it not for your own cloud provider or whatever, providing those instructions helps us get it even further and more mature. Any bugs you run into or any problems that you have, those kind of things help us really fix it. So we're at that point when people can start. Before I would have said, don't use this unless you're just completely experimental. But I can say relatively confidently at this point that you can start trying it for actually trying it out, not just to play around with, but to try it with real things that you want to try out with WebAssembly. So that's where the state of Krustlet as the project is at, I would say.
Okay, very interesting. Peter was just asking in Discord. He says, thank you for the great talk. And he asks whether you could share your slides in Discord with us, because he saw some interesting code snippets that you showed today, but which are not in your blog post. Is it possible to get your slides? Is that okay?
Yes, I can actually export them right now, and I will upload them to my, I have I'll actually drop it in the Discord when I'm done, but I have my site that has all my slides from different talks, and I can put them up there.
Ah, very good. Very good. Thank you. Thank you very much. I have another one, while maybe some other questions will come from the community. This is only barely related to your talk, but it's very important for me personally, because I do a lot of work with kids and young coders. I teach at a school for computer science. You talked about the differences between Go and Rust. And when I take a look at the Austrian university system, people mainly learn managed languages like C#, like Java, a little bit of C++, and sometimes in earlier times, a little bit of Go. But Rust isn't already there. What do you think? Should young coders, people who just starting coding, who just come into coding, is Rust a good language to get started, to learn coding, or is it something that you should take a look at later on? What are your 2 cents on that?
I think based on my experience with it, especially like with Go versus Rust, I think Go is probably a better starter language. However, it depends on the group and how well like each group would handle it, because I think certain types of groups and age groups could handle it very well. I do think it's something that could definitely be introduced by the time someone gets to high school here in the US. Is it primary school over there in Europe? That I think it's definitely something that they can learn very well. But I think for especially younger coders, I think there's a lot there to grasp that might not be very intuitive. And maybe that's because my brain wasn't trained right. So maybe if we started people earlier, they'd understand the concept of ownership better. But and ownership and borrowing and kind of how like lifetimes, those kind of things that pop up pretty quickly when you're in Rust. So I definitely think anyone could probably learn it, though it might be easier to start on something like a Python or a Go at a younger age and then move on to something like Rust. And I'd say Rust rather than C or C++ or anything, because you're able to do low level things, but you're doing it in a way that teaches you to be, I think, be safer with the way you code things. And then when you do something in C++ or C, you go, oh, well, I don't have ownership checking here, but how can I handle that myself?
Yeah, thank you very much. Thank you very much for this for this point of view. Taylor, I think we currently don't have any other questions. And also, I think the timing is great. We really enjoyed your talk. If I take a look at the messages here in Discord, you sparked a lot of ideas in people's minds. And that's exactly why we are doing this meetup. So thank you very much for sharing your insight. It was super interesting. We never had somebody here who has a lot of experience in Go and Rust, and especially that one. Well, I personally liked it a lot. I hope you enjoyed this hour here at the Rust Linz meetup.
Yeah, I did. Thank you so much. It's been great. Hopefully this is interesting for people and helpful to kind of give a different view on things than I think most people are used to seeing with Rust. So
absolutely. And we are going to do a lot of things with the community here in Austria, in Germany. And I'm pretty sure we haven't seen us for the last time. We will see each other, hopefully, in upcoming meetups, conferences, or whatever. Thank you very much. And I hope you will stay a little bit around in the Discord server, answer some questions. And yeah, thank you. Thank you very much for that.
Thank you so much.
Yeah, and with that, we are at the end of today's Rust Linz meetup. Thank you very much, everybody, joining us through Zoom, through YouTube. I hope you enjoyed the presentation. Join our Discord server, check the messages there, maybe help people who are just starting with Rust. And yeah, follow us because we already have fixed the next date for next month's Rust meetup. We also have fixed one speaker. If we still have have one speaker slot open. So if you are interested in sharing some insights, doing a talk, maybe on a project you did, or maybe a topic that you are really really want to talk or share about, let us know. rust-linz.at is our website. Go there. You will find the call for papers there. With that, I would like to close today's meetup. Again, thank you for being here. See you next month. Bye.